Hi, everyone. Alan Schimmel, DevOps.com, and we're here for another great DevOps.com webinar. Today's webinar is brought to us by our friends at VictorOps, who we've known actually since the day they launched and have watched the company grow over the years. Today's webinar is exploring Prometheus, combining metrics and alerting to improve incident management workflows. If you're interested in this kind of thing, you're going to find this a very, very interesting webinar. Before we get started and introduce our esteemed panel for today, though, let me first give a quick second on our GoToWebinar control panel. We have set aside time for questions today, and what we'd ask is that if you could use the question section of your control panel, type your questions in real time. Don't wait till the end, because we may not see it in time, and depending how many questions there are, it could get lost in the queue. Type your questions in as they come to you. This way they're there. You don't have to worry about forgetting them. We'll have them. We'll get them in. And, you know, these webinars are so much better when we have questions from the audience. Secondly, we're going to be doing some polling questions today. These are short questions with multiple choice answers, but I can't tell you from sitting on the other side of the webinar screen how important it is to get that kind of feedback from the audience. It really kind of shows us where you guys are, what you're thinking, and it helps us to frame where we go with the conversation. So please take the second or two to vote, contribute on the polls so that we have a better flavor and a better vision of who's out there. Lastly, chat down at the bottom. So, you know, you all have other chat tools that you can use to talk among yourselves. But here on our GoToWebinar control panels, we use the chat for technical support. So if for some reason the video or the slides are not advancing, or your sound is off, but you can still type in the chat window, please do so. And we do have engineers standing by who will try to help you with whatever your problem may be. So chat for technical issues, questions for questions, and please be participants, not just lumps on the log here. You know, be active, participate in our polls. With that being said, let's turn to today's webinar. As I said, it's exploring Prometheus, combining metrics and alerting to improve incident management workflows. Let's meet our panel members. So if we can go to our next slide. Okay. Straight from Ireland, we have Brian Brazel, founder of Robust Perception. And you could read his bio up there. But Brian, welcome to a DevOps.com webinar.
Hello. Happy to be here.
Thank you. And secondly, we have none other than Matthew Boeckman, technology strategist and longtime DevOps advocate. Matthew, it's a pleasure to have you on again.
Thanks for having me, Alan. Hi, everybody.
Okay. With that being said, guys, I'm going to turn it over to you, Matthew, I guess, and we'll go from there.
Yeah, that sounds great. Thank you, Alan, for that introduction, and thanks everyone who's taken the time to join us on the call today. We hope we've got some interesting content for everyone interested in getting better at incident management. So just as a good level set, I think for the conversation today, I want to introduce everyone to one of the ways that we think about incident management maturity at VictorOps. And as we've experienced and engaged with teams from all sorts of different industries and different places in a spectrum of DevOps adoption, different technical stacks, we've really tried to distill our understanding of their incident management practice into a couple of different buckets or phases, if you will. And certainly at the top left, where we have a core metric like mean time to resolution fairly negatively impacted, we see teams that are fairly reactive. There's not a lot of operational awareness in their stack. There's poor collaboration in their teams. And really monitoring and detection tends to be ad hoc and using vendor-supplied default values. These teams tend to be, exactly as the title implies, very reactive to the alerts and the incidents that they have to manage. As teams start to focus on their culture and their systems, they move down this stack to a place of more maturity and correspondingly see a meaningful reduction in their time to resolve as incidents come through. Those additional phases include tactical, where we start to instrument our alerting and our metrics. where we have more defined roles and processes in terms of how an incident might get managed. And there's, I think, a foundation of collaboration between the teams. With additional effort and maturity, we start to see really, truly instrumented monitoring and detection systems, a focus on keeping alerts actionable, good collaboration across all teams for different types of incidents, and very well understood processes and documentation for teams to rely on in times of crisis. And then lastly, at sort of the highest level of maturity, we see not just instrumentation, but real full stack automation and awareness through monitoring and alerting. Teams tend to find ways to self-heal incidents before having to alert humans or wake them up in the middle of the night. There's deep and meaningful collaboration between teams, and a focus starts to turn more on learning as the focus of reaction fades in the background. So for whoever you are on the call, we sort of expect that the topics we're going to cover today hopefully will be broad enough to encompass the spectrum of incident management maturity, and I'm certain that some of the things we'll discuss will sound fairly basic to some, but very new to others. So we're going to try and give you a good overview of Prometheus as a detection and monitoring system, a metrics gathering system, and lots of other exciting things you can do with it, as well as VictorOps as an incident management platform. So hopefully we'll do a good job of trying to bring this fairly deep technical field to the broad audience that I think we have on the call. So our format is essentially Brian is going to spend some time talking about Prometheus, and then we'll segue into an integration discussion of how you can get Prometheus wired into VictorOps, and then I'll spend some time at the end of the webinar talking about VictorOps and incident management in a more abstract way. So with that, I'm going to let Brian kick off and talk us through Prometheus and monitoring.
Thanks, Matthew. So I'm Brian, and I'm one of the developers on Prometheus. And I'd like to start by just talking about monitoring, because when I talk to people about monitoring, lots of them have different ideas about what it means. Like some people are taking like facilities monitoring, like the temperature of a building. Others people are wondering, hey, are you seeing if I'm looking at Facebook when I'm at work? And that's not the sort of thing we're talking about here. We're talking about computer systems and the software that runs on them and seeing how those go. So when it comes for a definition of monitoring, I kind of see it as three things plus one extra. The first is knowing when things go wrong, which you more commonly think of as alerting. And because you want to call in someone to fix a problem. When you actually know there's a problem, you need to be able to debug that problem, have dashboards, dig down, look at logs, all that sort of thing to figure out what the problem is so you can fix it. Now, alerting and debugging tend to be on the scale of minutes to hours, maybe days. But when you're looking at months and years, you're into trending. The simplest case is capacity planning. How many machines will I need in a year's time? How much is that cache being hit? Is that going up or down? How much are these features being used by specific users? And then this guides technical decisions and this guides business decisions. The final one is the odd one out, which is to feed data into other systems. Because, well, when all you've got a hammer, everything starts to look like a monitoring problem. So sometimes people just use the monitoring system for plumbing, which kind of happens. Now, obviously today we're looking mainly at alerting, because we're looking at things in the context of getting it to an incident management system like VictorOps so that it can be handled from there. Next slide, please. So when we're talking about alerting then, we need to realize that if you want to go from the reactive state down to tactical, integrated, holistic, we need to recognize that humans are limited. You can't just have humans automatically react to everything all the time. Because if you're alerting on all of that, you're just going to get overwhelmed. You're going to suffer from what's called alert fatigue, pager fatigue, and fundamentally get to a point where your engineers are burnt out. You're not dealing with actual problems as efficiently as they could be. You're having outages, and ultimately you're going to lose staff and customers, which is what no one wants. So the thing is, if you think about your system and your customers that use it, the things you care about are something like user-facing latency. Because if a website's slow, people aren't going to use it that much. And there are hundreds of ways that a website could be slow. It could be a load balancer is overloaded. It could be a switch is overloaded. The machine's overloaded. There's a software bug. There's hundreds, maybe even thousands of ways this could happen. And trying to alert on every single way that things can go wrong isn't really possible. There's just too many ways. However, wouldn't it be good if we could alert directly on high latency? Because that's the actual thing we care about. Normally, we've got a user-facing system, like a web app. We're talking about high latency and error rates, and that's something, if we can alert on directly, that's one alert. It's much less likely you'll be getting false positive alerts waking you up in the middle of the night for no reason. Next slide, please. So we'll take an example, canonical example of an alert where this happens. There are monitoring systems out there which don't allow you to alert on latency, but you can look at machine level CPU usage, and this has problems. So you just have an alert on, hey, 80% of the CPU in the machine is used. But this causes false positives because, well, your nightly cron jobs are running. Like, well, you want those to run, but then you have to up the threshold so they don't page you. And on the other hand, if you have a deadlock inside your application, it's going to use no CPU and you're never going to notice it. So the result of this is that you're going to end up with spammy alerts, which all of your on-calls are going to be ignoring because, well, they prefer sleep. And this isn't good for anyone. So we'll go now to the first poll as to how often this happens for you.
So the poll here.
I'm here, Matt. I'm sorry. So actionable alerts are drowning you in a series of useless notifications. Select just one of the following answers, please. I wake up weekly for no good reason. I receive more than I'd like, but we've made progress. We've dialed in the signal to noise in alerting, and management believes we'll miss something. So, of course, we take a little liberty here, but where are you in terms of dealing, with the amount of alerts versus signal to noise ratio and actionable? And if you guys can answer, come on, just half of you voted so far. Let's get some more, please. It might take you a while to figure out the answers, but we'll close voting down here in another 5, 4, 3, 2, 1. Okay, answers, please. That's promising, guys. What do you think?
Yeah.
What stands out to me is this bottom poll answer. The management believes we'll miss something, and I think it's certainly something that I've observed in my own practice. I've probably been guilty of in my own practice, and I know through our outreach with customers and just people working in the space, it's a pretty common theme. Lots of the responders feel like this alert is pure noise and there's no reason to keep having it, and they're frustrated with it. But someone in management doesn't want that alert turned off because, well, it might keep us, it might save us one day from a real critical incident. And I think that's going to be really interesting in the context of how Prometheus can handle alerting from a statistical significance standpoint, and really using, analytic techniques to be more confident about when an alert should fire versus just defaulting to alerting all the time. So hopefully we'll be able to help some of the folks on the call with this.
Sure. Yeah. Because actually we can cover this if we move on towards the next slide. Because what you want to do here is have alerts that are more meaningful and the capability to be meaningful. So if you think about your microservices architecture, whatever architecture you have, and let's say you've got an API server between a front end and your backend databases. Inside that API server, there's kind of like a mini architecture with all the libraries connected together in it. And each of those is kind of like a mini server that you want the standard metrics about. So metrics and event logs are two kind of different approaches to monitoring. So with event logs, you're getting every single request and its information about it, like your Apache logs or anything else like that. And then metrics are just giving you a general idea of what's going on. So they're much a broader view of what's going on, whereas logs are a depth view. But the principle of Prometheus is in each of these little libraries, next slide please, that we add in some instrumentation so we know what's going on. And all this information is then fed back into Prometheus. We have all the statistical information to work on. And in fact, we go a step further. Next slide, please. And we don't just think about an individual machine or an individual process. We think about your service. So you can imagine if you have 10 web servers or 10 front ends, and one of them is slightly slow, but the overall service is still providing sufficient SLA, sufficient responsivity to users, why should you wake someone up in the middle of the night because that single machine has high CPU? As long as the actual latency to users is meeting your SLA and providing a good enough service, that can be dealt with in the morning. So by just tying things back to your SLAs and latency, error rates, saturation, looking at these sort of metrics will give you a better way to think about these problems rather than just trying to calculate 100 ways in which that latency could be high. Next slide, please. The other thing that you have Prometheus is that we are part of the Cloud Native Computing Foundation because Prometheus itself was kind of designed for a dynamic container-based environment. Because if you're using a more traditional system, everything's based on the machine. And, you know, if we go back 20 years, you had the MySQL machine, the Apache machine, and so on, but we're no longer in this place. We're in a place where 10, 20, 50 different containers could be on a single machine, and they move around all the time. So machine-based approaches are limited for there. So instead, what Prometheus we do is that we're trying to look across the entire service and see its overall performance, rather than caring about exactly what lives where. Because with something like Kubernetes, that can change in an instant. And we've got service discovery to automatically, well, talk to Kubernetes and find out where everything is. And when we've pulled in all this data from all of these, we have the Prometheus query language, which is PromQL. And this lets you slice and dice, aggregate, calculate your latencies, your error rates, your percentiles, and do basically anything you can usefully want to do with time series data. So it's a very powerful way to analyze and visualize this information. Next slide. And then there's the question of like, okay, so this sounds awesome. How do I actually get my data in? So as we showed there a few slides ago, what you want to do is instrument all your code to add the business metrics. Because, well, we don't know what your business metrics are. So you need to instrument that yourself. So there's like 13 or 14 client libraries for all the popular languages. So you can just go and do that. It's normally only a few lines of code to go and instrument things. And the advantages are that if a library you're using is instrumented, you can get that for free. So in fact, recently for Prometheus itself, we added a library called GoContract to give us more insight into how Prometheus is using HTTP connections, because someone out there had already written that for us. So that makes it much easier for now when someone reports a problem in this area. Now, obviously, you aren't going to have source code for everything. There's always going to be third-party code where it's difficult or challenging to change the code. So the good news is that we have over 200 integrations called exporters, which allow you to pull out data from these systems. So for example, cAdvisor is going to get you all your Docker and container stats, memory usage, CPU usage, all those sort of things. SNMP is handled, JMX, all those standard things. If you've got an existing Nagios system or NRP, there are ways of getting that data out. In fact, people have even hooked in Minecraft and Factorio because, well, my friend who did the Minecraft, he really likes having lots of plugins in his Minecraft server, so he does care about the FPS. So this sort of stuff is pretty easy to do, and it's easy to get information for all the infrastructure you already have before you even start out adjusting your code to expand things further. So there's kind of this level where you've got your infrastructure monitoring, and then you can build up onto that and start doing your application monitoring, which I think brings us into our next poll.
There we go. Sorry.
Okay. Where does your team fit on the monitoring and alerting spectrum? Okay. Basic monitoring is a challenge. We employ infrastructure monitoring. We employ infrastructure and application performance monitoring. And we employ infrastructure, application performance, and
synthetic monitoring.
Synthetic monitoring, sorry. Thank you, Mike. And guys, again, if you could vote here, so is it, do you have just one? Do you have two? Do you have all three? Or maybe you don't even have one, right? And that's okay. That's what we're here for. So we'll close off voting in about 5, 4, 3, 2, 1. All right, polls show. Well, that's good. Not even basic monitoring is a challenge, is way, way low. But at the same, it's also the same exact as the high end of where we have all three. So work to be done there. But the sweet spot appears to be at in between the 2 and 3. Matthew, Brian, any thoughts on that?
That's generally happy.
Yeah.
Honestly, like.
Go ahead, Brian. Sorry.
Oh, well, so honestly, 12% of people not even having basic monitoring is a bit concerning, but it's good to know that like 88% of people have basic monitoring in place and can build up from there.
Yeah, and I thought what was really encouraging, and we've been doing these polls with DevOps.com now for a while, and I feel like as a slightly unscientific heuristic that trend line's increasing, where we're seeing more and more teams having a very robust set of monitoring and detection systems in place. That 45% on the 3 line was pretty exciting, but I think it creates a separate challenge for teams to manage that we're trying to speak to today, which is great. Now we have alerts firing from all kinds of different systems. How do we make sure that those alerts are actionable and that we're not just getting woken up from 5 different monitoring sources instead of 1? So that's interesting.
Yeah, it is an important question of, is the monitoring system you have providing value or just waking you up?
Right.
Yeah. So if you move on then to actually alerting. So we have all this data that we've pulled from your infrastructure, pulled from your applications, and it's in the Prometheus server, nice and reliably. Then using the PromptUL query language, we can rule any map you can graph, you can alert on as well, and alerts are sent to our alert manager. Next slide, please. And the Alert Manager is actually a relatively sophisticated piece of technology, because in Prometheus, not every alert is going to wake you up. Instead, we try to group similar alerts together and route them as well, and then throttle the notifications in order to increase the utility of each alert and increase the signal-to-noise ratio. So you can imagine if you had, say, a rack switch was to fail, and there are, let's say, 50 machines in that rack, which is a very big rack. You can imagine getting 50 alerts because that single rack switch failed is not exactly good. That's not helping the person debugging it. So the Alert Manager, depending on how you configure it, you can say, hey, if a rack switch fails, send me 1 email for all of them. Or in fact, for the entire data center, just treat it as 1 and only send me 1 notification for things that are down once an hour. And you have that sort of flexibility in order to improve your signal-to-noise ratio, because it's normal for things to fail together. It's also got a HA mode, which is actually designed to work reliably during network partitions. So if you have 2 data centers, each of them running an Alert Manager, and one of them fails, the other one will just keep on sending out the alerts to VictorOps. So as long as one of your Alert Managers still has internet access and Prometheus can talk to it, your alerts will keep on working. You might get double page, but that's better than not having your alerts at all. And other systems are supported as well, like you have Slack, email, all the usual suspects, plus a generic integration. So that kind of takes us on to the next slide, just showing an example of some of the integrations we have. And yeah, so that's roughly how Prometheus works. We pull in the data, we can analyze it locally, send out alerts to the Alert Manager, and then they go to systems like VictorOps. Matthew, over to you.
Thanks, Brian. So integrating the VictorOps platform with Prometheus is really simple. If you're on the call and you're familiar with Prometheus, you set up VictorOps as a receiver for some of the routing logic in the Alert Manager, and then a very light API key integration ensures that those alerts get delivered to our platform. And then as is illustrated here, those alerts can still be delivered outside of our platform, also via email or SMS or ChatOps or whatever mechanism you might want. So with that, let me talk a little bit about where VictorOps sits in a traditional stack. So on the left, we have whatever the systems are that we're actually watching. I love the fact that one of the icons we've chosen here is a mushroom cloud. Sometimes that is how those systems make us feel. And then to the right of that, we've got our monitoring systems. This is very much where Prometheus lives, as well as lots of other monitoring and detection platforms. And then VictorOps really is a place to ingest all of the alerts that are being sent from those monitoring systems, apply standard and advanced on-call routing logic, to ensure that the right people, whether they're developers, operations, support, database, whoever the engineer might be that needs to respond to that alert, is notified. And then VictorOps provides a collaboration platform for the team to use and leverage, not only in the moment to sort of fight the proverbial fire, but also in the after-action report or after-action analysis as teams try to dig in and understand what led to that undesirable condition. So a different way of saying the same thing is we can ingest alerts from really every system in the world, and Prometheus is one of them. And I said every system in the world. That's probably not strictly accurate, but we have hundreds of integrations, and the number of different systems that we can ingest alerts from is growing. And really that's the value, I think, that one of the primary values that any incident management platform offers you For folks who are familiar with the logos on this slide, most of these systems have some concept of alerting as part of their monitoring package. But what, as a practitioner, as a team, you don't want to do is re-implement your schedules and your rotations and your alerting logic in 6 or 7 different places. Not only is that unpleasant on the front end, but as an ongoing maintenance activity, having to make changes to 6 or 7 different implementations of alerting logic isn't just, candidly, isn't the best use of your time. So offloading that to an incident management platform like VO is we think, one of those differentiating factors that help team get out of the reactive phase of incident management. So quick product walkthrough for us in our UI, which is both web and mobile native. You can always see everyone on the team, what roles they might play or what teams they're a member of. Who is on call is easily knowable through the little green dot there. And then you can chat and engage with these folks. We have the timeline, which has been sort of a central offering of our product since launch. The timeline really is just that. It's a timeline of all of the incidents and activities that are going on in your environment. So across Prometheus and Splunk and AppDynamics and whatever else the rest of your stack might look like, the timeline is the integrated place where you can see telemetry from all of those systems and what the team might be doing about it. And then lastly is our incident panel, where you can dig into individual incidents and learn more about them and what the state of that incident is in your on-call workflow. All of this happens essentially through the magic of routing keys. So you can, when you integrate VictorOps with any upstream monitoring source, determine a routing key associated with alerts from that system like Prometheus, and then use that routing key as a tag for whatever alerting and notification logic you want to employ. In this example, the routing key ops is going to get sent to the ops team, which is fairly obvious, but nice to show it in a slide here. We similarly, as you could kind of guess, have a pretty strong support, if not excellent support, for an idea of teams. Individuals in the VictorOps system can be a member of one or more teams. Escalation rules and logic can be applied to individuals or teams. Which gives you a nice way to sort of break out. What we see typically is on-call is either going to be handled in a functional team arrangement, so all of the ops team, all of the back-end developers, all of the data team, or increasingly we see instead of functional alignment, alignment along service or business goals. So you may have a team that's composed of front-end, back-end, ops, and data functional engineers, but they're responsible for several services, and so all the alerts associated with those services get routed to that team. We have very robust scheduling logic. It's easy to understand when you're on call and what you're going to be on call for, and to schedule that out really as far in the future as you need, so on-call teams can make plans and have a life and sometimes not respond to their pager. Similarly, there are rotations that can be part of those scheduling logic. And then escalations, which really are the backstop that I think is critical for any successful formalized procedure to on-call alerting and rotations. Your escalation is essentially the what happens if somebody doesn't respond, or what happens if the incident remains unresolved for some period of time. And the most obvious example of that is if I have paged someone and they have not acknowledged receipt of that page in 5 minutes, escalate perhaps to the next person on call, to someone in a different team, or whoever we think is appropriate. One of the things that we think really sets the incident management platform at VictorOps apart is our Transmogrifier. This is, other than a clever name, a really interesting way that you can take data in an alert payload, which you see on the right half of the screen, and use that to drive rules logic to add context or transformations of the alert fields themselves. In this example, we're saying that when we get an alert related to host.123.xyz, we're going to annotate that alert with a runbook. We're going to create a link that will create a JIRA ticket automatically. We'll also add a link to a dashboard coming out of Cassandra showing disk utilization. And you can kind of go on. You get the idea here. We feel that for many of us, we've received alerts from systems for years that are really cryptic. Host x27 is out of bounds. Not super helpful. trying to get responders closer to a resolution by giving them contextual information that's meaningful given the alert conditions that we see, we think is one of the techniques that really effective teams have adopted, and that's really what the Transmogrifier is. It allows you to do pattern matching and basic pattern match search on any field in an event, and then to do a whole variety of transformations of that alert as it's received by the responder to try and set them up for success at fighting this specific fire. We've talked a little bit about it today, but I'll expand on this. We also feel pretty strongly that Chanos, both as a sort of an abstract collaboration tool, is transforming the DevOps industry, but particularly as it applies to incident management. Having well-defined processes and procedures for your team is important, and Chanos is one of those things that we think is super differentiating. So the idea here is whether you're using the VictorOps chat client or Slack or HipChat or whatever a ChatOps platform your team might have adopted, having those two things tightly integrated so that as teams are working together on problems, they see the telemetry coming out of the incident management system, they're able to operate both their infrastructure and the incident management system through a single interface. This saves as individuals are trying to context switch between different tools and gives you one coherent view into the actions that the team's taken to try and resolve an incident. And that gets us to our third poll,
Yes.
Which sort of sets up the next conversation point. Go ahead, Alan.
All righty. So this should be an easier one, I hope. Are you running post-mortem or post-incident analysis? I would hope everyone does something, but options are no, we don't review incidents at all. Number 2, yes, but only in response to major events. Number 3, all major and some minor events are reviewed. Yes, for every event as they take place. And then finally, yes, we have a standing meeting to review incidents. So that, hopefully you fit into one of those boxes, and if you guys can vote, we'll, we got a big, quick response. Let's come on, these last few laggards get in there, and we'll close voting down here in 5, 4, 3, 2, 1. Okay, survey says.
Hey, that's awesome.
Is it, Matthew? I was hoping. I'm the eternal optimist.
For me, the only 4% not reviewing incidents is the awesome part, and I think it would be awesome. It would be even more awesome to see those numbers shift further down. Which to me, the way that I read this is the highly effective teams have a great deal of process, and I hate to say the word ceremony because that's sometimes a bad word, but they've gotten muscle memory around post-incident analysis. And I think that we all know and have all been present when there are little events, these minor events as they're listed here in this poll, that occur that often are indicators of something wider going on in our environment. And if we don't take the time as a DevOps team to sit down and analyze the little things along the big things, we don't really get off that break-fix cycle and move truly into the holistic quadrant. But the fact that the vast majority of everybody on the call is in some habit of post-incident analysis is, I think, great.
Yeah. The other thing as well is that any major incident, normally there's 4, 5, 6 different things that went wrong. So taking in and fixing each of them will prevent all sorts of future problems.
Absolutely. Yeah, and I said muscle memory, and that's a thing that here. There we go. There's our next slide. That's a thing that I think is really hard for teams to develop, and most of my career has been in startups and small businesses that are trying to grow. And certainly the major event is always easy to get buy-in for everybody to sit down in a meeting and talk about, but having the discipline within your team to either as they occur or as a standing meeting to review sort of system health is again, I think we think just super critical. So to that end, I'd like to invite everybody to try and grab a copy of Jason Hand's Post-Incident Reviews, Learning from Failure for Improved Incident Response. It's a book recently released with O'Reilly and Jason. Jason's one of the evangelists here at VictorOps. And what we try to focus folks on in that book is first and maybe foremost moving away from this idea of post-mortem. Unless you're a surgeon practicing in healthcare or hopefully not in a battlefield, really nobody has died. And post-mortem is a term that our industry has adopted for whatever reason that we think really improperly focuses teams on the negative aspects of incident management. Often post-mortem is performed alongside a root cause analysis, which the two tend to be a little overly focused on blame. And we think certainly that in DevOps culture, moving away from blame and moving towards learning is really what can be transformative, certainly for your culture, but more meaningfully in your team's ability to collaborate and effectively manage these complex systems that we're all asked to manage. So this post-incident review should be a great reference for anybody who's trying to think about how they can make their process more successful, how they can help their culture grow to develop that muscle memory I spoke about, and particularly how we can sort of marry this new reality of continuous improvement and continuous deployment and continuous delivery to operational stability. And so there's a part of the VictorOps product here that can help folks be successful there as well. Essentially, we give you an editable view of the timeline. So if you know that an event started at 8:03 in the morning and it lasted for 2 hours and 37 minutes, you can just sort of mark that and annotate that in the VictorOps timeline, and then use that combination of the alert stream and the Chanos events that occurred within that timeline to sort of guide your post-incident analysis. When we all sit down to talk about what occurred, working from memory certainly is an approach. Working with clear data to support the narrative as we develop it is we think, pretty meaningful. So that really brings us to the end of the presentation. As we wind down here, what we, as I said at the beginning of the call, have tried to talk about is a lot of the things that are interesting and meaningful to incident management teams across the spectrum. And hopefully you found both the conversation from Brian around Prometheus and some of the ways that it can transform your management of alerting, and some of the things that I've shared about VictorOps and the way you can use an incident management platform to transform your notification and on-call practices. Hopefully those together can help you move from a reactive to a more holistic approach to incident management. And that's where we see very much the reduction in core metric of time to resolve. Teams just get inherently better at managing systems. But perhaps more meaningful for us as engineers and as humans is our lives as on-call practitioners get better. We get off of the I'm getting woken up for unactionable things. We get out of the arguing over alerts are significant. We get some of our life back, and we really find collaboration with our teammates in the heat of the moment. So I think, Brian, is there anything else that you'd like to add as we wrap up here?
No, I think you've covered it pretty well. Like that, how using these tools together is ultimately about providing a good service while not burning out.
Absolutely.
All right. With that being said, guys, let's jump in here. We do have a couple of questions from the audience that I'd like to get to, and we can come from there. So question number one, though, comes from our audience. Do you have any machine learning components which can learn from previous errors and predict the future issues?
I assume that's for me.
Yeah, I'll let you take that, Brian. Go ahead.
Yeah. So in Prometheus, the answer is we do not, because the thing is that I've seen many people attempt this, and it doesn't work in practice. So there's a great quote from John Osball, who's with Etsy, I think it is, about how basically any form of machine learning to auto set up alerts and so on, it doesn't work. The problem is, if you have maybe 10 metrics and you're trying to do machine learning on that, you can probably get that to work. But when you're in a system like Prometheus, where hundreds of thousands, millions, tens of millions of metrics is normal, there's just so much noise in there that you can't really do much with it because you basically need to spend an engineer or a statistician per, just to permanently keep an eye on that thing. So it doesn't work out compared to, well, just set a static threshold. Because at the end of the day, you have an SLA that's something like, hey, 95th percentile latency needs to be under 500 milliseconds, so just set that as your alert. Or, well, probably 450 to be safe, so you have some breathing room. But if you're looking at symptom-based alerts, you don't need very complex math and machine learning and having to throw statisticians and engineers into developing and maintaining these, and you're going to get just as good results with simple static alerts in our experience. However, if you have that in Prometheus, you can pull it out into OR or into other systems and do whatever analysis you want on top of that. For example, it's very handy for capacity planning to do some very basic regression, just to figure out, hey, how much CPU am I spending per request, and then capacity planning from there.
I think I'll add just briefly that machine learning being a very high goal, as Brian rightly said, a thing that Prometheus as a time series system does offer that I think is still pretty transformative is the ability to do some predictive alerting. And at least for me, Brian mentioned static alerts. I came early in my career as a deep and passionate Nagios practitioner, and I still love Nagios, but really in that system, you're looking at purely static thresholds. When the disk is above 90%, send an alert. But you end up getting in an awful lot of exception handling there, where there are some disks that are supposed to be at 90%. And I think one of the things that's interesting that you can do with Prometheus is say, instead of alerting on a static threshold, let's alert on rate of change, which might be a more interesting indicator of a disk filling up in that example than just a raw static threshold. So definitely agree with Brian's assessment, but certainly I want to remind folks that there's still some interesting things you can do statistically with Prometheus. That are a little south of machine learning, but way north of just a static threshold.
Yeah. There's the predict linear function as well, which will predict how full your disk will be in hours, so that can be useful. But a lot of the things that people are asking about machine learning is like, can I point machine learning at the database and it'll tell me what the problems are? And that doesn't work. However, if you know what the problem looks like and you can write a mathematical function to describe that, then you can probably create an alert for that in Prometheus.
Excellent. So let's move on to another question as we have some time here. Matthew, this one I think might be more up your alley to start with, and that is, we've been hearing a lot about idle practices that don't translate well into modern systems. Can you want to, I'm not going to ask you to confirm or deny it, because either way you're going to alienate someone. But what are your views about idle, in modern world, in modern everyday practice now?
I certainly won't step into the potential flame war that question could ignite fully, but I think that if I look at idle, what served ITIL practitioners really well is a very process-driven approach to incident management, and I think that I generally agree with process as being an important component of incident management, and perhaps where ITIL is struggling today is keeping up with the rate of change. I've given a couple of talks on this topic, and it's really, if you can take a step back from your day-to-day and think about what the rate of change to a system might have looked like 6 years ago, where we were having maybe at the best people in the industry 6 years ago were doing weekly releases, and then whatever they're doing in their ops schedule, probably less than weekly. And you look today and see teams that are doing dozens of deployments a day. Idle practices have to evolve to be more agile, for lack of a better word, in the ways that they enable teams to manage these more complex realities. And so I think my bias outside of any particular methodology is I want to make sure that a smart, motivated person has information and access to be able to manage a problem. And if ITIL's helping me do that, awesome. And if ITIL isn't helping me accomplish that, then we do need to find other methods. So it's certainly going to be interesting to see how it's able to adapt and morph to this new, highly really change as a vector now, not a state. It's going to be interesting to see how ITIL kind of adapts to that.
Sure. Well, and they'll be coming out, from what I'm hearing, rumors of a new Idle X, sort of like, I don't know if it's Idle X or Idle 10, like the iPhone. But we'll see what happens there. Brian, here's another question for you, and that is, there was some buzz or at least some talk about the scalability of Prometheus. Can you give us some insight into where that is now?
So Prometheus is very scalable. So, for example, one of our users for, I think, 2 years now or something is Cloudflare, who deal with many, many websites on the internet. Like, they have over 115 data centers, and they deal with like 5 million requests per second. And they're using Prometheus and haven't really hit many scaling issues. Like, they're running, 185 Prometheus servers, each of them ingesting up to like 70,000 samples a second, which in Prometheus terms isn't much, and handling millions of time series per machine. And that all is fine. And in fact, we're soon going to release Prometheus 2.0, which it's going to cut resource usage and increase scalability by about a factor of 5 or so on all the key metrics like CPU and RAM. So as long as you're using Prometheus for what it's designed for, which is metrics, not logs, it should scale no problem.
Got it. All right, another good question from the audience for you again, Brian. As we are maintaining stats data points 24/7, can we get stats on server downtime over a period of time, like a week or a month? And then sort of what caused the downtime? Does Prometheus return data points that big? Possible?
So, like, if Prometheus is trying to request information from the machine and it's down, all you're going to know is that it's down and how long our attempted request took to realize it was down. And that's all the information we have, because we depend on an exporter, normally the node exporter on Unix systems, the WY exporter on Windows, to tell us about how the machine is doing. So if the machine is down and we can't talk to it, there's not much we can tell. However, if you're using black box monitoring like Ping or SSH monitoring, you might be able to get a little bit more information. Using the probability query language, though, you can use normally the average over time function to then tell that, hey, it was up for 95% of the time, and do that sort of analysis from there. But for figuring out what's wrong, like Prometheus is good for figuring out generally, oh, there's a problem here, this machine is down, but you still need to send in a human to reboot it or replace the RAM.
And I think I'll extend that and say that that's very much the complementary product offering from VictorOps and the idea of our timeline and post-incident analysis. So if we replay the question through our systems, host has crashed, Prometheus stops receiving data from it, Prometheus also stops being able to ping it, so Prometheus sends an alert through VictorOps. The team is notified, our timeline shows that alert. One of the practitioners on the team acknowledges the alert. They say in chat, hey, it looks like this is down, heading to the data center. They arrive at the data center, it is down, I'm restarting it. I'm making it this workflow as I go, but you get the idea is between the two systems, you do sit in a place that in post-incident analysis, you can go through and reconstruct everything and then file essentially that post-incident report with causality as you understand it for why a single host may have gone offline.
And the other thing to consider is that a single host going down, or any system going hard down like that, like it's powered off, is normally a pretty easy one to debug. Yeah. Where the real value you get with these technologies is when the system is slow, or slow sometimes, or slow on a Tuesday. And at that point, because you're still getting some level of metrics from the system, being able to drill down and see which subsystem is a problem. Because, well, if the machine's hard down, the only information point we have is it's hard down, and maybe there's less power and less network going on. But that's all we can tell. But if we can see inside what's left of the running system, and get, oh, it's using this much CPU, the RAM increased this much, there was this much garbage collection going on, there was this many requests, oh, there was this weird request, that sort of thing really helps narrow down what's going on. And that's where the real value is. Because you kind of have to move beyond, oh, this machine is down, to, well, is the service working? And then stepping from there for, oh, it's that critical machine is down, and working from there, and taking things in those broad terms as you go towards the holistic quadrant.
Yeah, I think really building on that, the term or the DevOps phrase of the year is observability for me, and I think that's the advantage that both of our products really offer for DevOps teams is the ability to observe in all of the richness the data that these systems are generating, and Brian just gave a couple of great off-the-cuff examples, like it's slow on Tuesday when it's raining in Seattle. This is not the sort of thing you're going to be able to infer directly without a great deal of data and insight empowering your team. Probably, hopefully your systems aren't actually affected by rain in Seattle, but I know we've all had those sorts of problems, and trying to figure them out is tough without great data and great analytics tools to understand it.
It's probably a point-to-point Wi-Fi link.
Exactly. So maybe maybe your systems are slow because it's raining in Seattle. Who knows?
Yeah, it's not inconceivable.
Right.
The real question is, if it rains in Ireland, does it affect things in Seattle? But we'll move on
considering how many data centers there are in Ireland, probably.
Yeah, this is true. All right, next question's for Matthew. Matthew, this gets down really to the nitty-gritty of a lot of this stuff. You know, when we look at how fast systems are changing, realistically, are we ever going to be able to achieve holistic incident management maturity?
I think so, and I think you know, that question as it's phrased is tough to sort of answer in specific. But you know, there are teams who have built deeply complex hybrid cloud microservice architecture with continuous deployment, who are delivering on the promises of SLAs to the business. And I think that when we say the term holistic, a big part of it is linked to the theme that Brian has I think reiterated many times nicely. You know, those teams are aware of the details, but they don't get bogged down in the details. They've built resilience into their design, and the cost of that resilience is complexity, but resilience in a way that they can lose half of their container fleet, or they can lose 20% of the servers that they're relying on, or they can lose an entire public cloud. In one of the companies that I previously worked for, we used to have a failure scenario that was a comet hits Northern Virginia, and we want to be able to survive that. And to reach that level of maturity, you know, you have to get out of caring about a server or a particular disk in your environment, and you have to have designs that are resilient to not care about that. And then from an incident management standpoint, you have to be focused on the things that you do care about, which are overall system health, which are SLAs that we've committed back to the business. I think a different reference that we haven't mentioned so far, anybody who's really passionate about moving forward in this path really has to read the O'Reilly Site Reliability Engineering book. I think it treats a lot of these topics that we've discussed today in much greater detail, and can help you get out of thinking about systems. I had a tweet just the other day in which I said we've got to stop thinking about systems and start systems thinking, and that's how you move towards true holistic management of your incidents, instead of, you know, being on the break fix cycle of lots of alerts about things that don't matter.
Yeah, fair enough. Fair enough. Guys, we are about almost out of time here. And I wanted to just take a few moments to, first of all, Matthew, it's always a pleasure having you on, hearing your voice and your even temperament, chock full of intelligence, experience, and good information. So thanks so much for appearing today.
Well, thank you for the compliment, Alan. It's always a pleasure to join you.
Thank you. And Brian, joining, you know, I know it's not exactly the middle of the day over there, so I appreciate you taking time out of your evening with us and giving us a little bit of background on the Prometheus, you know, whole project and everything going on there, and sharing your knowledge with our audience today. And thank you very much.
Thanks. I'm glad to share.
Thank you. We'd love to have you back on, and we'd love to hear more about this. I'd also like to thank our friends at VictorOps for sponsoring today's webinar. You know, VictorOps does a great job, I think, of reaching out to the audience, reaching out to the DevOps community. Continue to do so. We'll have more in the future, I hope. But I think we're going to call it a wrap on today's show at this point. So Matthew, Brian, thank you for joining us. Thank you, everyone, for listening. I forgot to mention, today's webinar is being recorded. It'll be available up on our DevOps TV YouTube channel. And I'm sure you'll also, VictorOps will be reaching out, I think, to everyone registered. And there will be a link to how you can get a hold of Jason's book, which is an excellent book, the new O'Reilly book. And we'll take it from there. But until next time, this is Alan Schimmel for DevOps.com. Thanks for joining us today on another DevOps.com webinar, and we'll see you soon. Take care, everyone.